In this tutorial, we will show how to work with an arbitrary express schema using ODA Step SDK. The source code of the module is located in Solution, Step, EX Step Tutorials. We will write our code in the method tutorial_01. First, let us add a new express schema with the name tutorial_name. Type schema name inherited from string with a maximum size of 256 symbols. Next, declare a class GFPoint with coordinates of the real type. Declare a class vector. Declare a class GFCurve, a base class for all curves. It has an attribute name. GFCircle class is inherited from the GFCurve class. It has a center attribute, a reference to a point, and a radius attribute, type real. Next, GFPolyline is inherited from GFCurve with attribute points, an array of references to points in a model. Save the schema to a file. Now let's switch to the source code. Create a new session and do not forget to close it. Load the schema from the file we've just created. Next, if the schema initialization was successful, create a repository. Using the recently created schema inside the repository, create a model and turn the model into the edit mode. Let's check the first results. We created a schema. Initialization was successful. Create and open a repository. Create an empty model and turn it to edit mode. Move on further. Inside a model, create a point, a circle center. Next, create a circle with the name Just Circle. Set the previously created point as the circle center. Set the radius value to 10. Next, create 2 points that form a line. Next, create a polyline with the name Just Polyline. Set the previously created pair of points as the polyline coordinates. Now save the model that was created to a step physical file and open it after saving. Let's see the steps. A circle is created, 2 points are created, and these points will form a polyline. The model is saved to a file, and the file is loaded back. Open the file and look at its content. A point, circle center, 2 points that form a polyline. Let's move on with the code. Turn the model to edit mode. Iterate through all the circles. Use the object ID to get the application instance. And for every application instance, find the rule named WR_positive_radius. This rule checks whether the circle is created correctly. If this rule is found, check whether this rule works for the instance. If the radius is not positive, replace its value with the absolute value. Save the results in the fixed file. Change the circle radius to -10 for testing purposes. Build and run the example. A file is created and saved. Next, the file is loaded back. An issue is revealed. WR underscore positive underscore radius rule is not added to the schema. Now, pay attention. There are no code changes, just a couple of new strings added to the schema file. We add the WR underscore positive underscore radius rule to the GF circle class. And the rule just checks whether the radius is positive. Now save the schema. Restart the test application. Now we successfully find the WR underscore positive underscore radius rule. Check whether the rule is true for the application instance. It is not, so we change the radius value and save the fixed file. Open the newly created fixed file. The radius is positive. Now, restore the positive radius value in the code. Rebuild and run the test application. The WR underscore positive underscore radius rule is found. The radius is positive, so no additional steps are needed.